It's platform as a service, right? Okay. So we're going to learn about this PAAS and how does it work in basic steps, in stages. Okay. First, I'll give you an example of service PAAS. It's well-known service as vercel. You have vercel, render, data pool, amplify. All of them are kind of PAAS services. They build upon a very common logic on containerization. What is containerization? It's similar to building your own, having your own virtual machines where you don't have overlapping file dependencies, right? So let's say this was built on React. This guy was made on React plus. So when you cannot run these two in the same environment. So what do we do? Create a virtual environment. So a virtual environment for this particular one. This one. So they have their own isolated process. So basically this is the idea of containerization. Lots of data centers, it's going to servers, and it's going to run your projects. It's going to run and deploy your projects. So if they have lots of dependencies, it's going to be a big of a deal for them even to run all those things once. So that's the idea of containerization. Civil project, anything. So it can be React, Vine, Flask. This kind of projects. So each of them has a different running code. So what we do, we build, what does Docker do? It's going to build a Docker file. And which is going to be using another set of, which will be using set of commands and a set of existing Docker images. So you have this. You have your folder. This can be used. Your folder, the project directory. Let's call this directory. Okay. There's a project directory, then you'll have a Docker file. You build a Docker file, you create a Docker file that's going to use existing Docker images and a set of commands. That'll create a Docker image. A Docker image. And you just need to ship. This is a final container. This Docker image is the container. It's the blueprint to run a particular project. Now, I can ship this. So any other environment, you need to do this from your server side. Right? So this will be done by you, first of all. The idea of Docker is this. And a particular deployer or server is going to just use this Docker and run the container. And most services, this particular building of Docker images is this thing here. We just clear that. So most images are built on this. So this is the structure of what we can do right now. So we have a project directory which may exist on different services, use services like a Flask service or Civil or it can have its own command to run, right? So you're going to use existing Docker images. Well, what do I mean by that? So Docker already has a bunch of Docker templates, so a bunch of set of rules on how to set up the environments, and so you have all this stuff in a place called Docker Hub. It's going to use very popular Docker. So whenever you pull an image, it's going to start with here. So you have a bunch of TensorFlow, PyTorch, LangChain, NGX, Alpine, Mongo, lots of Postgres images, this kind of stuff. So yes, the basic idea is to have this platform. And right now we have to automate this structure. Now I need to give a given structure of how this works. Alright. So we have to try to make this automation. Before you could start to know how if you try to find out how this works, you need to know that these images, Docker images, are immutable. These images, once they cannot be changed. That is it, right? That's one thing, but so we also need to take care of the check for changes. Changes. That's going to check if there is a change in the folder, because if you updates or something stuff like that. Change found. Yes. Then I'm going to create another one. This or else no, just keep running this holding machine. Right? We need to look for this, right? So this is one of the important stuff that we do. Run the whole image. There is no change. Create a new image. Create a new image, and then to deploy this. Now, the idea of doing all this stuff, right? The thing is, if I'm having no image at all, so I don't have to deploy it again. So I'm just going to keep serving the image. So this is the idea. And if I need to talk about deployment, deploy is a way of serving it into a port where anyone can access it. So if you are making it deployable in localhost, you can access it through localhost. It's like making a doorway to your project. So if you're serving this project in there, no one will be able to access it. So if you open up in a particular doorway, so those doorways are set up and just deploy it. Now, right. So when you deploy it, we serve a port. We serve in a port. So open. I'll just say available. Right? We'll just serve it in a port. Look for changes. This is why do we need this? Alright. Updates. Right? Running updates. Now, this is the basic idea. Now, two things I need to take care of. This whole project has to be efficient, no delays, and second thing, work for different type of flask. Not flask. I mean, I work for different kind of platforms, services. And anyone can be simultaneously. So my service is product. If I'm a service, many users will be trying to access my service. So I need to work simultaneously. Work continuously. For different users. Simultaneously for different users. So and many users should be able to try access my service and actually get like that. Alright. Cool. So how do we make this service? First problem. Let's talk about this particular problem. The idea of having different users is that your platform shouldn't, once I start a platform engine, your platform shouldn't shut down if I close it. So one way of doing that is when you start a parent process, start a parent process. You need to make your, let's say parent process is your service to like maybe the front end website or maybe a CLI website that starts this engine. Maybe your vercel front end, right? So the parent process is this regular front end. This doesn't, when I close this shouldn't shut down here. So if I'm at here, the children process done independent of processes. That's one thing the whole you should take care of. Now, another thing we should get when there are lots of deployment, when there is deployment at once, we need a type of structure to keep a track of them. So, tracking system, maybe a queue that follows a route. Sure. The rules can be anything like FIFO, some priority based rules, or etc. Or maybe priority based if you get as platform service some money and all this, some money to pay customers, pay users, be better than free users. Some sort of any kind of stuff like that. So this is the second thing I need to take care of. That will help me to take care of work simultaneously. Another problem we need to take care of is efficient delay and automatic dates. Alright. What for different kind of services? I'm going to take this. How do you take care of this particular section? There are many rules. Right now, we already have a bunch of templates, right? So maybe ask user if you have a Docker file. If not, you have to make yourself known. User Docker. Just if yes, use that, of course. Yes, use that. Else, what are you gonna do? I'm gonna try to write my own file. My PAAS will create. Now there are two ways of doing this now. Okay. First of all, is bunch of default statements. Bunch of statements that figures out by looking at my project. Looking at my projects, config files, headers. Right, I can do this, which is an old way, or a new way is give it to them. Why not? You have a project directory, just give it to them, make it own Docker file, and you won't charge anything for that. So, go for all types of this. Cool. If you have a Docker file for a particular project, you're able to do it, right? Alright. Now that's another part we need to play efficient and no delays. Efficient. What I mean by that is when we are trying to redeploy, right, there should be any no delays, and so what we can use is a policy called the green blue policy. So we have a mapping, internal mapping of the ports, right? And since old container is there, and I want to deploy a new container. What I'm going to do, before, what we used to do is we have this old container in one particular port and a new container in the same port. So when we try to deploy it, the gap between that deployment, it may take some few seconds or even few minutes if the project is huge, right? So if the project is huge, this whole redeployment process, taking the whole port and deploying it again, this whole minute, even for a few minutes, your server is going to be down. So when I access that web page, I won't be able to access it because it's been deployed again. But that doesn't happen in new services in vercels, right? So whenever you push an update in GitHub, or you don't see any lag. You see either the old version has been loaded or the new version has been loaded. You don't see any particular lag. So why does it happen? They follow a new policy called renew policy. What they do, when they're just going to deploy this new container in another port, all right? And your old container is being served in another port. This is going to reroute it. When this new container works perfectly fine, let's say user has access to port A. User always goes to port A, right? So if I'm going to port A, before what used to happen is I'm directly serving old container in port A. That was a mistake, because then when I'm making an update and I deploy a new container, there's going to be a whole lot of delay on it. So when I go to port A, the port A will be service down. There will be errors, like files, some kind of errors that this DNS address is not found, or this stuff. You can put this kind of stuff on that until the new container is totally deployed. But now what happens is, I'm just going to go and port A, which will be controlled by this particular. My old container is going to be served in some port B. Port B. And my new container is going to be served in some port C. Now my internal mapping of ports will take care that whenever I go to port A, I'm just going to be served to port B or port C. This we need a rerouting. Reroute port A to port B until new container starts working. Then reroute to port C. So this should be the idea. So whenever there has to be rerouting too, that either so this old container and new container is going to be served in different ports, which user doesn't know about it. User only knows port A. So when I go to port A, the rerouting tool will give it to port B if the service is working for that, or even port C when the new service starts working. So this way I kill the delay of redeployment. And automatic updates on that's either the idea of automatic updates is that just that the fact that you listen to if there's any changes. One way, continuous listen to any file change. If any change, remember Docker files, Docker images are immutable, so you have to create another one. When the file changes, any changes, redeploy again. But this way it's very heavy, right? Even if you try to write a comment itself, let's say a comment, even a small comment will detect, this is going to be detected by this particular method, and it's going to redeploy it again. It's very heavy and expensive. We don't want that. Instead of that, I'm going to look for, if it's a GitHub, I'm going to look for new pushes. If there's any change, deploy it. That works. So I'm going to use GitHub. That's going to take care of the listening and detecting any pushes in the backend. So this is what we need. This is what should our platform do. And for user side, and for user sides, there has to be an interface, right? Create another one. User side, I need an interface. Just like it can be a CLI interface or web app. Anything works. I should be able to, I should be able to do two things here. This should be able to give, should provide user with the list of all commands. That is deploy commands and on the side, and also link. So they can either link their projects or by just uploading the whole file or linking to this kind of stuff, anything else. So they can either upload the factory or maybe give Git or URL. Or maybe, maybe just link it to, if it's working in the local directory, link it. So, like, so a user should be able to do that, right? And also an important thing right now, I should be also able to declare my environment variables, not just Python. So user should also be declare variables. So in the backend, what happens is you have the variables. Let's try this. It's should work. So, I'll go set the solution of these things. Yeah, the solution of this is you will then declare it. You just create while deploying an image, create the home env file, just has all the variables, right? Alright. So yeah, these are things I should be able to do in a SaaS project. So this is how an SaaS works. I've already made a very simple version of this that works only with default commands, only with some set of platforms like NGX, React, and Civil, and Vite. So what does it have? It has a CLI command. So I've already uploaded this particular workflow in GitHub. I'm going to keep on updating this, make it more advanced and more advanced. So I'll upload it in versions. You can look at it, it's in GitHub. So it's called Miniverse, and this is a simple, very basic way of just trying to do that. So, yes, that's the whole project that we're going to do. And